So when dealing with this problem, we know a hypotenuse of a right triangle, we know a leg of the right triangle. Now, for many of you, that's going to be enough where you can go ahead and set up your Pythagorean theorem straight away. But if not, it's always a good idea to go ahead and draw a picture on it. And because it's going to help you to visualize what's happening. Now, picture or not, your setup should be something along the lines of 18 squared plus something else squared that's going to equal the 30 squared. Because remember, the hypotenuse has to be the one that's by itself, and the hypotenuse is 30 here. Now that's something, I need to give it a name. It doesn't matter what you name it. Some people will use A or B. I'm going to use X at the moment, but there's nothing magical about using X. In fact, you'll see me use other letters other times. And so I'm going to call that an X squared here in my equation. So now I'm solving it. And so the first thing we do is we can actually do the squaring. So that gives me 324 plus X squared equals 900. And so once we get here, notice we're solving for X squared. So I want to subtract 324 from both sides of our equation. So we're going to have X squared equals 576. Now in order to solve that then, in order to get the X by itself, instead of it being X squared, that means I actually have to do the square root of the 576. And what is the square root of 576?
24. Should we write this down?
Now, one little detail on this one, though. In this particular problem, we are actually given units. We are told that both of these were in inches. And so my final answer is actually going to be 24 inches. Today we're continuing our work with fractions that we've been doing all year. We have done operations on all types of fractions. We've done multiplication, division, addition, subtraction, reducing. What we haven't done, though, is dealt with any mixed numbers along the way. They've always been either just fractions or improper fractions. Well, today we're going to also be able to integrate mixed numbers into the whole picture. So starting visually for this problem, if I'm going to represent 14 thirds visually, I first need to think about what a third looks like. And so you see I drew the little box that represents a hole there. So 1/3 would be the amount that one of those would take to be shaded. Now, part of the reason why mixed numbers give people trouble is because if I'm going to look at 14 thirds, it looks like this. 14 thirds is a big mess. But what we're trying to do here is we're trying to take some order out of that. So if I had these 14 thirds and I wanted to put these in a way that made some sense, I'd line them all up into sets of 3, because remember, each one is a third. And so I could line them up into little sets of 3. So I can see then how many holes do I have, because every single one of these bars here that's that size represents a hole. So notice how many holes we have then. Out of that 14, we ended up with 4 holes. But now notice what was left over. After pulling out those 4 holes, I still had 2 left over. This last bar down here, it represents 2 thirds. Because remember, each one of those is a third. And so for a final answer here then, as a mixed number, this equals 4 2/3. It's that visual way of seeing it. And so this is how we could actually come up with this answer visually, like if we actually wanted to take the pieces and move them around. But we don't really want to have to do that every single time. We don't want to have to take this big mess of pieces and try to sift them together. So the mathematical approach, the way that we can do it without having to move stuff around physically every single time, is we answer these questions. The first question is, how many times does 3 go into 14? So how many times does 3 go into 14? we're talking about like how many times does it multiply into 14. So think about sets of 3. 1 3, of course, is 3. 2 threes is 6. 3 threes is 9. 4 threes is 12. 5 threes is 15. Now when we talk about these, I needed to go in a whole number of times. 15 was too many. I don't care about the 15. So what I care about then was that I could get up to 12. And again, how many threes did it take us to get to 12?
4.
4 of them. And so for the first question that we ask ourselves, how many times does 3 go into 14? It goes in 4 times. Basically, that is the way that we can mathematically say, how many bars can I make out of all these pieces? How many whole bars can I take out of all those? But then after we do all of those, I need to know how many are left over. Well, how many are left over? Remember that 4 gave me 12 thirds. So how many were left over? Out of the 14, there would be 2 left over. And so we get 4 whole times, so that's 4 wholes,
So it goes in 4 times, and then
and
there's
2 of the thirds left over. All right, so for this first problem that we're going to practice now without the picture, we do the same thing. We ask the same question. So the first question is, how many times does 5 go into 21? And so then we see that 5 goes into 21 4 whole times, because that would get us up to 20. So if that gets us up to 20, how many are left over? 1. And remember that each of those that's left over represents a fifth. So it's 4 and 1/5. So for doing each of these now, let's actually check. I do the same thought process. So for the first one, how many times does 10 go into 83? It goes in 8 whole times. Now, 10 times 8 is 80, which means that I have 3 left over. So that's 8 and 3/10.
Oh, yeah.
Okay, for the second one, I say how many times does 2 go into 13? It goes in 6 whole times. Notice the better you know your multiplication tables, the easier these are. And if you aren't especially good with your multiplication tables, you're going to get better by practicing these. And that's a good thing too. So 6 times 2 gives me the 12. So that means I have 1 left over to get up to the 13. And for the last one, the 31 thirds. And so we say how many times does 3 go into 31? And it goes in 10 times. And then we say, okay, how many are left over? Well, 3 times 10 is 30. Well, notice that leaves 1 left over to get up to the 31. So it's 10 and 1/3. All right, so in these problems, yeah, there's going to be a couple what do we do when kind of moments here. So let's take a look at the first one, 21/4. This one's actually fairly straightforward compared to the others. We say how many times does 4 go into 21? It goes in 5 times. Because that gets us up to 20. That's as close as we can go without going over. That's our goal. And so if that gets me up to 20, notice I have 1 left over. So it's 5 wholes with 1/4 left over. So it's 5 and 1/4. The second one, how many times does 4 go into 24? It goes in 6 times. Well, 4 times 6 is 24. So notice there's none left over. Well, I don't really want to write 0 over 4. That's a bit unnecessary. Because 0 over 4 is just 0. So 24 over 4, it is just 6. We saw problems like this before where we would see, oh, well, I have 24 over 4, which equals a whole number. So I just give it as the whole number. And nothing's changed. Just because we know how to deal with mixed numbers, that didn't change at all. All of the stuff that we know from before still works all the same. Now this last one, there's actually 2 different approaches to this last one. I'm going to start with the approach that I think most people take at the start. And that is, how many times does 4 go into 26?
25.
Well,
6.
notice the closest we can get is 24 again. That's the closest we can get. So it goes in 6 times. And if that gets us up to 24, how many are left over?
2 over 4.
And so it gives us 6 2/4. But I actually don't want to give this as my final answer. I do need to reduce my answers.
6 and 1.
We always need to reduce our answers. And so when you take a look at a mixed number and think reducing, the 6 that's a whole number, it stays a 6. Nothing is going to change the whole number part. What would change is the 2/4. 2/4, of course, reduces to be 1/2. And so this is the final answer we're looking for here, is 6 1/2.
Oh, 2/4.
6 1/2.
I knew that, Mr.
But now, remember I said at the start of this one that there were actually 2 different ways you could have gone about it? So I'm going to show you the other way as well, because some of you will prefer doing it the way I just did it, and some of you will prefer reducing at the start. Because you'll notice that 26 over 4, I could have reduced that before I did anything with a mixed number, because they're both divisible by 2. And so I could start by turning that into 13 halves, and I get that again by dividing the 26 and the 4 both by 2. And if I started by reducing it and then turned it into a mixed number, 2 goes into 13 6 times with 1 left over. 6 1/2. Same thing. You will get the same answer either way. And it also proves why reducing it doesn't change the whole number part. Why the whole number is still going to be 6 even when we reduce it.